Hi, I'm Bailey with My Math Experts, and today I'm going to show you how to solve the following system of equations. So as we can see here, we have two equations, 3x plus 4y equals 11, and x minus 2y equals negative 3. And something you might notice here is that this is lined up really nicely so that we have kind of our x's on top of each other, our y's on top of each other, and our constants on top of each other. So that's a good indicator that we're going to want to solve this system of equations using something called elimination. And the way elimination works is that basically our goal is to either add both of these equations together or subtract both of these equations from each other, one from the other, so that one of the variables gets canceled out completely. So for example, if you had something like 3x minus 4y equals 12, and you had negative 3x plus 2y equals 10, if you add these two equations together, you're going to get 3x plus negative 3x, that's 0. The x's go away. They cancel. They're eliminated. That's why it's called elimination. And then negative 4y plus 2y is negative 2y, and 12 plus 10 is 22. And now this is a one-variable equation that you can solve. You can solve for y. You can get y by itself by dividing both sides by negative 2 here and getting that y equals negative 11. So that, in this example, it's really nice because we have 3x and negative 3x. Those just cancel each other out right away. But you can tell the problem here is that we don't have the same number on either of these variables yet. We have 3x and 1x, and we have 4y and negative 2y. Neither of those are the same yet, so they're not going to be able to cancel each other out. So in this problem that we're given, we're actually going to need to modify one of the equations first so that it becomes the same number so that they can cancel out. So I'm seeing, for example, we have 3x. Actually, let's do the y's. I'm noticing we have positive 4y and we have negative 2y. So I'm thinking if we could just turn this negative 2 on the bottom into a negative 4, then when we add them together, the y's are going to cancel out. So what I'm going to do is multiply this bottom equation by 2. And when you do that, that's going to multiply every single term by 2. So this x times 2 is going to turn into 2x. Negative 2y times 2 is going to be negative 4y. And negative 3 times 2 is going to be negative 6. We didn't do anything to the first equation, so that's going to stay the same. And then, hey, look at this. Now we have positive 4y and negative 4y. And now when we add those two equations together, they're going to cancel each other out. So now let's do that. 3x plus 2x is 5x. Like I said, these are going to cancel out. And this is going to equal 11 plus negative 6 is 5. And then we can solve this equation for x. So divide both sides by 5, and we get x equals 1. However, we are not completely done solving this system of equations yet. Because a system of equations, the answer is always in an xy coordinate pair. And currently, we have the x value. We know the x value is 1, but we don't know what the y value is yet. So let's solve for the y value. So to solve for the y value, you just substitute your x value that you just found back into one of the two original equations. It doesn't matter which one you choose. So let's choose the first one, for example, 3x plus 4y equals 11. Substitute 1 for x in there that we just figured out. So 3 times 1 plus 4y equals 11. 3 times 1 is 3. Plus 4y equals 11. And now, this again is just a one-variable equation that you can solve for y. You can get y by itself. So to get y by itself, let's subtract 3 on both sides. 11 minus 3 is 8. And then divide by 4 on both sides to get that y equals 2. So then your final coordinate pair here, your answer to this system of equations, is just going to be x1, y2. That is your solution to the system of equations. And a way that you can check this, by the way, is by substituting your coordinate pair back into both of the original equations and making sure that it works for both of them. It's very important that it works for both of them. So we already know it works for the first one because we used the first one to figure out what y was in the first place. But let's really quickly just check in the second one and make sure it works. This is going to be minus 4. And then negative 3 equals negative 3. Voila, our solution worked for both equations. Thanks, hope that helped.